We're going to look at the volumes of spheres. Some of the problems on Pearson for your assignment are going to have you just finding the volume of spheres. Some of them are going to be like giving you the volume and having you work backwards and possibly going back and forth between volume and surface area. So the formula for the volume of a sphere is 4/3 pi r cubed. So be sure you remember that it's the radius to the third power cubed. And you can cube in Desmos. And if we're working backwards, we'll have to cube root. But to cube in Desmos, you'll use this A to the B button, and then you'll type in the 3. And I'll be showing you how to use Desmos for doing these problems. So here I have a sphere and the radius is 12. So we want to do the volume of it. So 4/3 pi times the radius of 12 cubed. Now the radius is the only part that gets cubed. So I'm going to do that first, and then I'm going to be multiplying by that 4/3, and then I will multiply by pi. So the 12 is getting cubed. So 12, and then a to the b, and then the 3 to get that power of 3. So 1,728. And that is the number that I am going to be multiplying by 4/3 and then by pi. I lost my number. 1,728 times 4 divided by 3, and then pi. So 7,238.2. And that's centimeters cubed. So that's just like working forward, how you cube your radius and how you'll simplify the formula. Here is one where we are working backwards. A sphere has a volume of 972 pi cubic meters. We want to find the surface area. So what we're going to be doing is we're going to be using the volume to find the radius, and then use the radius to get the surface area. Remember that the surface area is 4 pi r squared from last week, and the volume is what we're doing today, 4/3 pi r cubed. What I love about this problem is that they did give it to us in terms of pi, so we can just cancel the pi's out and be using, nice numbers through our work. The first step is to isolate the r cubed. And to isolate the r cubed, you're going to be multiplying by the reciprocal of 4/3, 3/4. Very important to remember to do that. That's like the number one mistake that I have seen through the years, is people trying to get rid of this fraction by multiplying by 4/3 or trying to divide by 4/3, which is okay to do as long as you use proper parentheses, but it kind of messes you up. Remember that when you divide fractions, you're multiplying by the reciprocal, and that's why we do that. So you can see that this would be 12 divided by 12, which reduces to 1. So these fractions are canceling each other out, and that was the whole goal of that, giving us r cubed. And then 972 times 3 divided by 4 is 729. And then we need to cube root. So I'm going to be going into Desmos to show you how to do a cube root. And how you do a cube root in Desmos is you will pick functions, and then often it starts out in this trig area where we were doing trigonometry a couple of weeks ago. You need to go to miscellaneous, and then you need to pick this one here where it's got a number n and then a root. So you'll push that. you'll type in a 3 because you want to do the cube root. And then in the gray box, you're going to type in the number that you want to do the cube root of. And you get 9. Another way to do a cube root is to take your number that you want to do, push a to the b, and in your power, make it 1/3. And that will do a cube root. A square root would be a power of 1/2, and a fourth root would be a power of 1/4. So those are a couple of ways to do a cube root using Desmos, but we are getting 9. So the radius is 9 meters. And now we're going to go over to the surface area. So to get the surface area, we're going to do 4 pi times 9 squared. So it's going to be 81 times 4, which is 324 pi meters squared for the surface area. If they wanted exact form, that would be the answer. And if they want you to round, you're going to multiply by pi, which would give you 1017.9 meters squared. And that's how you can use a given volume, work backwards, find a radius, plug it in for surface area. Sometimes they'll give you a surface area and have you go to volume. So it just kind of depends. And you just use the formula and you do algebra and you work your way backwards to get the radius, and then you just plug that radius into the formula you wish to use.